So our first talk today, I'm going to read your bio first, but come on,
Okay.
stand up. Yeah. He has experience in design, operation, optimization of process equipment, and operations management in cross-functional teams. At Valero Energy, he led multiple operational practice improvements, focusing on equipment preparation and troubleshooting, as well as building tool sets and policies to facilitate continued operational excellence. With ExxonMobil, while supporting refinery units as a process engineer, he helped develop and lead strategic, payback projects to help reinforce refinery profitability during poor market conditions. He has extensive process engineering experience coupled with hands-on in the field operational know-how to drive elegant and practical solutions. Mr. Jacobson has supported or operated every major refinery process unit across his years of industrial experience. Since 2020 at BEC, he has focused on holistic troubleshooting and improvement initiatives on fired equipment and energy optimization. He is a thermography subject matter expert with extensive experience in infrared cameras, pyrometers, as well as contact pyrometers. Grant, it's all yours.
Appreciate it. ChatGPT did a pretty good job writing my bio. I'm proud of it. But I don't know if you guys play with those tools, but they're fun. They do interesting things. But yeah, anyway, thanks for having me. I guess can everyone hear me here? Is this okay? Okay, cool. So, yeah, I'm just this random guy that hopefully will have some interesting things to show or talk about. If you haven't already noticed, I'm talking about kind of practical blocking and tackling kind of things. I'm honestly kind of surprised versus some of the other speakers here today. Like, I am not worthy. But yeah, I'm excited to get to chat a little bit. So I wanted to start with a safety moment that I thought was kind of fun. So obviously, like, I'm a fired equipment guy now. Like, I spend a lot of time looking at heaters, playing with heaters. The thing that I like to talk about is, look in your heaters. This is an infrared image from a specialty imager that actually like stays mounted up on a big olefin cracker. So this is all infrared technically, just, shown in a way that's visual. So this is brand new. This was started up in 2022. I don't have the actual video of what happens here. I just have these still shots, but still pretty interesting. If you haven't noticed, it's in Celsius. Anybody in the room able to go from 990 Celsius to Fahrenheit? I can call it out if that's, it's somebody. 1800. 1800, yeah. Good job. Thank you. Yeah, basically multiply by 2 if you're going to be, close enough. But yeah, these tubes are really freaking hot. This is an olefin cracker, usually like some sort of high P or HP microalloy, that kind of thing. Super, super hot. So anyway, this is the way tubes should look when you start up a heater and everything's okay. So here we are. This is in December 2023. My technical term for this is some spaghettification of tubes. The tubes are yielding. They're too hot. They're deforming. Amazingly, this image is supposedly on a live video in an operating shelter. That's pretty amazing. So yeah, normally if you open a heater and you see white hot tubes that have deformed, you start asking some questions. Maybe questions were asked. I don't know exactly what happened before this happened. So this is a tube failure. So right here, that is a tube separating and falling. You can actually see the fireball here in the IR image. Thankfully, because this is an olefin heater, the IR camera can actually see through that gas pretty well. It's kind of built to be able to see through that flame filter. But yeah, it's unfortunate to have a tube failure. Thankfully it didn't catastrophically fail the heater. I don't believe anybody was hurt, but a very avoidable thing. Just go look, go think. We can have all the smartest AI tools out there and all the coolest cameras and the nicest heaters. Like, this is not a bad design, but if you don't kind of do the basics and think about it, bad things will happen, unfortunately. So I just wanted to share that moment. Okay, now I'm going to get into the meat and potatoes. So this is Socrates. Anybody in the room remember Socrates? Good. I see some heads. Good. Good. Yeah, he's a good dude. And I bring him wherever Frank is. Frank Lu, there he is. He's in the back in the middle. I blame Frank for my love of Socrates. But yeah, so he had a triple filter test, and as Socrates aged and he got older, he started to realize like I only have so much time to ponder the things I want to ponder. So his time was valuable. So his triple filter test for you to get time with Socrates was supposedly, and again, this is I'm sure part myth, part legend. These were his 3 filter tests. Is it true? Is it good? And is it useful? So I hope in this quick little, 20-minute thing, I am going to pass Socrates' triple filter test. I would really love some feedback afterwards, folks. If you're like, hey, that was a terrible presentation, I didn't get anything from it, please let me know. I have thick skin. It won't bother me one bit. I'm here to help, teach people. Knowledge is power and all that. So anyway, that's that. So on to what we're actually doing. So this is the quick agenda. There will be a lot of text on some of these slides, and I'll probably just talk to it briefly and then go. If there's anything you got questions about, like I'm flexible. Gary, do you care if we stop for questions as we go, or do you like to the end?
What was yours?
Okay, cool. So I'm flexible. If there's something you see on the screen that you're passionate about, like get your hand up. Let's talk real quick. Or if you want to wait till the end, that's cool too. So this is basically what we're going to talk about today. I already had a bio. So yeah, Exxon and Valero, and now I work for Becht. I'm a bit of a generalist. So I'm a chemie, by background, a lot of time in process and ops. And then about 5 years ago, I really started to get into the weeds on fired equipment and thermography. And then over the years, I've gotten more into energy as well. So I will say I'm probably a novice in the world of energy. It's pretty cool. Like in the room here, like Alan, like there's people who helped invent pinch here. Which is cool. I'm like on the lead on the very novice side of all this. And then I try to participate in API 560 when I can. Okay. So, energy, and I wanted to talk a little bit about just kind of this culture. Realistically, in most refining or petrochemical applications, I guess any industrial application, what priority is energy? I can tell you it's not number 1, but what do you guys think it is? Second to last. Yeah, that's actually probably a good answer. Second to last. I would say everybody hopefully agrees safety is always number 1. Right. That's the feel I've always had, whether or not folks are good at it. Reliability, usually number 2. Profitability, usually number 3. You could say 2 and 3 are kind of interchangeable. You could go either way. And then number 4, energy, maybe. There might be another priority before energy. The other thing that makes it hard to focus on energy, and Gary, this is the old slide deck. That's okay. It'll be fine. I had a new chart that I found that was published 2 days ago that showed energy prices. Same story. This is just an outdated chart. I'm sorry. Energy prices in the US are low, right? There's not a lot of incentive for us to go chase a margin and all of these things on energy projects. So, these are the things kind of working against us. What I like to think about is, you can have your cake and eat it too. You can be reliable and be energy efficient. There's no reason you can't do both at the same time. Ditto to reliability to some extent, depending on what you're trying to do. And I would like to mention, when it comes to between US and Europe on the updated chart, which sorry, I don't have in this deck. Basically, it's 3 to 4 times more expensive for a megawatt hour right now in Europe than it is in the United States. So Europe has way more financial incentive to go be clever about energy, go build good things with energy. The US is a market that's probably less interested in chasing it, but it's pretty neat having forums like this where we're talking about it, thinking about it, because I think it's important. We don't want to let the Europeans get too far ahead of us. That's the way I feel. But I work in Europe all the time too, so they're good folks. So the things I'm going to talk about, and I'm sorry, of course, this is going to look kind of pitchy because this is coming from decks that I sell off of, but the intent is I'm just sharing knowledge. So sorry if I'm crossing any lines there. It's not intended to. So the 2 ways that we kind of approach energy stuff at Becht, we've got PEAK, which is a practical energy assessment, and then Bravo. Basically, it's high level, simple, practical. Bravo is the really detailed to get a bunch of really smart people looking at stuff, lots of things to do. These are just kind of, I think, some benchmarks you can think of in this realm. And there's other consultants that do other things. this is the way we kind of do it, but I wanted to show it to give you all a flavor for kind of like how people go tackle this stuff. And a lot of companies have this in-house. You know, you go to the Shells, you go to the Exxons, they have things like this that exist within their operating systems already. But like, you know, Peak for us is a lot simpler, a lot cheaper. You know, duration is much shorter, much smaller team, you know, only 3 people if we go to a Peak versus a Bravo, it's 6 to 8. You know, it just depends what you're doing. Also, like in Peak, which is what I'm going to talk about a little bit more today. On the practical side, it's really just kind of like a lot of checklists and spreadsheets. Like, I know that's not sexy, it's not cool. But when you're blocking and tackling, it's like culture and behavior and how are you communicating? What are you focusing on? When you get into the more complex stuff like Bravo, you know, you're talking pinch, you're talking how do you look at the energy efficiency of units, all sorts of fun balances and things like that, which you can do on simple sheets too. But these are kind of the 2 categories that I break this stuff into. Now I'm going to talk a little bit about practical energy assessments. I love this visual of an iceberg because this is what it's like in a lot of places when you're thinking energy efficiency. There's always some stuff you can see, you know, flaring and steam leaks are obvious. You can say, oh, they leave all the lights on all the time. Sorry, folks, like that doesn't matter in the grand scheme of things. But then there's all these other things that you can't necessarily see that really actually do matter. You know, one of my favorites is stripping steam. You'd be kind of amazed how many people just leave stripping steam in a nice, comfortable place. And it's so easy to have some simple targets, some simple controller logic to play with that. You're still on spec, everything's good, but you don't have to use as much steam. So all sorts of things like that. Bypasses are a great one. I love walking hot trains and cold trains on crude units. People accidentally leave bypasses open all the time. And most of the plants in the US, unfortunately, we're a bit older. We have less instrumentation. You don't have the TIs to be able to easily tell something's open. So, you know, walking it, thinking about things. The reflux one's a good one too. Sometimes you just spin up columns and you don't mean to. So anyway, lots of examples there. So the way that I kind of like to approach this practical stuff, you know, it's a tool that basically is just, it's a big Excel sheet. It's a fancy Excel sheet is the way I would think of it. But to be practical in energy, it's people and processes and practices. You know, it doesn't matter what kit you have built. If you're not running it the best you can, it doesn't matter. So the way that this score thing I'm going to show you here is set up, it's got 4 elements, 21 sub-elements, a bunch of different topics. The scoring is set up like this. If there's any ex-Valero folks or current Valero folks out there, this is where I was exposed to this kind of methodology. You'll probably recognize this. I think originally this idea came out of FlowServe. I think it was one of the roto vendors long ago. But I really kind of like this scoring mechanism for looking at how are you designed, how are your systems set up. Design doesn't just mean how's your plant built. It's what practice do you have in place? What culture do you have in place? And then effectiveness is, are you doing what you said you were going to do? So a pretty simple way to just kind of go look at stuff and rank yourself. And once you can kind of rank yourself, you get out of the qualitative feel and get a little more quantitative to see the gaps. This is like a little, performance matrix when we go do these kinds of energy assessments to kind of say, where are you versus the others out there? Not nearly as fancy as like the Solomons and those. This is more like, what do we see as folks working in this realm and focusing on energy? But that's what we kind of look at. And I like to mention, you see folks who we consider good, in our little tool here, based on these rankings and these elements, you get to 75% and you've probably caught most of the really good stuff. Do you really need to focus more at that point? Probably not. Then it's more of a maintain kind of position. The first time we go in and do stuff, you're going to be in the 20 or 30% range. And I'll show you an example of that in a minute. And then the last two here, just scoring's weighted in this kind of tool. So if you go build something or do something like this, think about the value behind the thing. Not all focus is the same. And I'll go to the next slide to kind of show that. So this is just a quick kind of screen capture from this little organization tool that we use. And when I'm talking about scoring and what matters, this is basically saying there's different weights for the different, sub elements like that we're looking at when we go do these. The gray is the max score and the yellow is the actual score from this example. So on this one, this was the first time, fuels refinery, mid-sized, 33% was their score. They were trying, but they were kind of on the beginning of their journey. So talking through like the four kind of big elements, and I'm not going line by line or anything. The key thing that they were doing right on the organizational side, they were starting to think about it. They're starting to talk about it. If you don't even talk about energy or think about your culture or what you want to improve on, there's no point in kind of doing it or focusing on this. So that was a big thing out of that. The other one that was really interesting, the panel operators weren't really empowered to go and chase things or do things better. It wasn't easy for them to see, oh, I could reduce the stripping steam, or why is my reflux so high on this column? There wasn't really any easy tools for them to watch that stuff with. So that's a big one too, organizationally, that we find. Going to the next one, benchmarks. So there's some good stuff out there. ISO 5001 and 2. There's also a really good list that the Department of Energy puts out that has a lot of good ideas based on different technologies that you might have in a petchem or refinery. Good things to look at. It's a really small piece of the whole puzzle. Like when we go do these, monitoring is a big one. KEV is K energy variable. Some people call them KPIs. Whatever you want to call it is cool. You got to have something built. You got to have something you're measuring or looking at. For KEVs, for most kind of mid-size, mid-complexity refineries, you're probably talking like 200. You don't need a bunch of these. And a lot of them are kind of cookie cutter. You can go easily Google the efficiency calculation for fired equipment. That's like the first one. It's just easy, folks. Here's the calc. Go build it, put it on every single, heater you got. Really easy to go chase. So stuff like that. And then systems. This one, in the way we kind of approach this, does get into the kit and the way you're built. So like how are you doing your excess oxygen, your stripping steam? How is your heat integration? Some of those things. But anyway, so that's an example. And this is really just an Excel sheet on steroids, integrated with like a web-based platform now. So after you have all that stuff done, how do you go get better? So it's nice to have some sort of roadmap. So I'm just going to show you guys, here's how we kind of look at it. It helps people kind of frame up, how do I go block and tackle and improve? So the one on the left there was the original. And then this is like the step case. Like, hey, if you go to this roadmap, which you're going to see on the next page, and try to adhere to these improvements, this is where you can go. So, the big areas that this plant was going to focus on were these three. And with that, they were hopefully going to get around 55%. Of course, we're making assumptions in the scoring when you do a shift case like that. But it helps to kind of visualize the path. That's the intent. I got all this stuff. Here's how I rank it. Then what should I go do first? What gives me the most bang for my buck? That's the point of doing something like this. This is another way to look at it. So this is a roadmap for this example. And these were all the different things to go focus on. So each one of these lines was basically, a simple slide or two saying, hey, go do this. Like, this is the thing that will help. And then, just some basic times. So it's not set in stone. You don't have to stick with it, but at least there's a plan you can try to go and do and execute. And then these are just a couple examples of what these things look like when we write them up. Pretty simple, pretty concise. The simpler you can make it, the more visual you can make it, the better for almost, I think, any, kind of industrial situation you're looking at. People have short attention spans. TikTok, everybody wants the 10, 20-second video kind of thing. I think we all need to be aware of that as engineers. We get really detailed, really wordy. We got to step back from that stuff sometimes if we want people to understand what we're trying to communicate. Okay. And then the next thing I wanted to step through, this is just kind of a fun example. And I believe this is like a crude column stripping steam example. So there's multiple things moving around on a crude column and like the way you might want to run it. So obviously you're off spec over here. You don't want to be over here. Max production, pretty easy, just doing your thing over here. You don't want to put so much steam in that you accidentally pinch yourself and your curve here has to go down. You accidentally limit yourself. But then somewhere kind of in between everything, this is like your most profitable point. I think it's also worth mentioning, and sorry, I totally goofed up the order there. There's going to be an energy optimum side and like a max production or, margin side. And it never makes sense to sacrifice margin for energy. Almost never. I'm sure there are examples out there where it does, but margin's almost always going to win. So I like thinking about things in this kind of manner. Like, where am I on the curve? You know, where's kind of the best direction I should go? Maybe it's not perfect, but you know, if you get this 80-20, you know, kind of right, you're in a better spot. And a lot of simple, you know, you got APCs, all those kinds of controllers. They're way more complex than this, but it's essentially all an APC is trying to do. It's just kind of feel. And you can build these simple correlations just in an Excel sheet, go data mine a bunch of stuff and build these curves, do, you know, a polyfit, and then boom, you got a KV you can go use on a crude column. Not super complex. This is getting into more complexity. I am not going to talk to this whole thing. When we get beyond kind of the practical stuff, the thing that I'm calling peak, you can also get into looking at, am I applying the technology the best way I can? If there's anybody familiar with EII and Solomon, you know, it's good stuff. The thing that's kind of frustrating sometimes about EII though, is you're compared to your competitors regardless of how the kit is set up. And yeah, there is complexity in there, for how they try and do it. But there's other tools and methods out there you can use that look at, hey, this is the way this plant from 1960 is built. What is its equivalent best it can do? And then you kind of rank yourself off of that and go focus on your improvements that way. So that's what this slide is kind of talking about, and just focusing those KPIs. Because there are some plants without significant capital, they're never going to be better than like a Solomon 3 on EII, or third quartile. And it is what it is, but it's kind of frustrating when you're one of those sites and you're just always screwed. You're just, oh, great, I'm always third or fourth quartile no matter what I do. It's kind of nice to look at benchmarks in different ways. And then you focus, what is the best I can do with what I have? How am I doing on time, Gary? Okay. Okay, great. I just wanted to speak briefly about pinch, and there are people in this room much more qualified than me to talk about pinch. But I like to share a little bit about it. I think it was developed in the 70s. Hopefully this is right. Alan, please yell at me if I'm wrong. Was it earlier? 78? Okay, good. Yeah, so about the right ballpark. Yeah, no, I'm not trying to throw any curveballs at anyone. Yeah. You know, pinch is good stuff. It's basically about, you know, optimizing the best you can, you know, within a system for your hot and your cold. You know, there's some specialized software still used for it. I believe those are still the ones that are kind of around. You know, basically a lot of plants that were built probably in the 80s and 90s, this was incorporated in the design. Plants that were built before that, you kind of got to go back and do a pinch study on it and figure out, okay, how do I want to move around my heat? And essentially, you're trying to build one of these. So this is a pinch curve, and you're trying to get the hot and the cold as close to each other as you can. You're trying to pinch them. This is like the 1,000, you know, mile overpass. So I know I'm probably butchering it, Alan, but I just wanted to mention, here is pinch. It's good stuff. If you're trying to go spend some capital and be more efficient in a plant, this is a good methodology to go look into a little bit more. A little bit just about how we like to apply pinch. It can get pretty complex and pretty costly. So I like to apply like the 80-20 kind of rule. Like whenever I've helped with one of these, and I'll admit, I've only helped with like 2 of them over the last 2 years, and I've never been crunching all the numbers. It's very much about where can you go to the best, you know, least amount of effort, most amount of value. So you don't want to just go in like carte blanche for an entire refinery and say, hey, I want to do pinch on everything. You want to go kind of look at the units and understand, okay, which ones probably have the best low hanging fruit? Because usually there's a couple that will be the best. So that's kind of the 80-20 rule there. You know, low capital first is important, which I kind of already hit on. And I'd like to just emphasize, like, pinch is good. It works. This isn't new and complex stuff. ChatGPT could probably go learn and do some of it. I haven't even thought about that yet. But yeah, I recommend it. It's a good tool. It's a good methodology. Last thing I just kind of wanted to show here around energy project ranking. So if you get into a big energy study and you're looking at, here's all of the opportunities I have across a given plant. I like kind of sorting it in this kind of method to help prioritize. Usually, and I'm I'm trying to remember. I've seen this out of some of the majors. This kind of curve. I don't remember which one it came from. I was going to give them credit for probably putting the idea out there first, but it's just looking at cost versus benefit. So on the bottom, you got cumulative cost. On the y-axis, you've got cumulative benefits. And then this helps you go prioritize what you want to do when. And usually if you go do a detailed, energy study or assessment, this is more kind of the Bravo thing that I was talking about. I wish I could remember what the heck it was called. I think Exxon called it GEMS, something like that. I don't know. Am I even in the right place? Yeah. Okay, it's GEMS. I forget what Shell called them, but I think this is a nice way to organize it and think about it. And if you do it with the right group of kind of SMEs who just know what to look at, you go find things that make a lot of sense usually without having to build anything or do anything. It's procedural. It's back to like the stripping steam mods, a little better KEV tools, stuff like that. The other one that's coming up more often nowadays is CO2 reduction. This graph here on the right is actually a Canadian refiner that was looking at some capital spend versus expected CO2 reduction by becoming more efficient. So that this is the other way people are kind of prioritizing these energy projects, what to do when, why to do what thing, magnitude of change, which is fun. And I think this is my last slide. Yep. Last one is, it's great to have some sort of tool or way to look at how am I doing? So you can build a model to basically predict, here's my energy use where I was, and hey, I start focusing on these things, and here's what I can actually do. Here's what I'm achieving. And this delta, if you kind of build this and maintain it, this is very helpful to keep the organization focused on the effort and showing that the effort's paying off, then it makes sense. I like doing things like this. So I know this is super simple, just trying to paint, broad strokes, good ways to look at things. I think that's it. Yeah.
We have time for a couple of questions.
Question for Grant.
Yeah.
So if I understand correctly, Beck does some kind of a study upfront to evaluate a site, for example, a refinery or a plant, and then figure out how much scope is there and where is the low hanging fruit that you can achieve without much investment. And then the rest obviously comes with some modifications and some adjustments more than just turning some knobs, right?
Yeah.
So how do you go around it? Like you start with a study and start with some kind of a monitoring program. How does the process work?
Yeah, and that
Raise this question.
Oh, sure. Yeah. So the question is essentially, so Beck, like, how do we kind of approach this? How do we organize it? That slide that had the peak and the Bravo thing on it, that's essentially the way we try to organize it. But like every place is different. Every time we kind of go play with one of these studies or help with something, it depends. The way to think about Beck, for those of you who don't know what the heck we are, it's just a small family company that has a lot of really smart people. Thankfully, I'm not one of them. And come and ask us weird questions. That's what we're good at. We might not know how to solve a certain thing, but we usually know where to point you. So anytime we get into this kind of stuff, it's okay, how the heck are you built? What are your goals? What do you want to do out of this? How do you want to communicate it? And we flex into that kind of, however it helps us or helps the client the most, that's our job. Yeah, did that kind of answer your question?
Yeah, it does. I was just wondering if there is some kind of established monitoring program that you put in first just to see how things are operating, how equipment is.
Honestly, I love to take whatever process historian exists. So if you've got, Pi or data visualization or whatever, I like living within those historian systems, and that's where you build your KVs. And you keep them as simple as you can, as maintainable as you can. Because, you've got engineers that are churning in and out of positions every 1 or 3 years, probably. So I think we're very much in the camp, keep it simple, stupid, do what you have that's very easy within your kind of IT realm. You can spend a bunch of money to go, buy some great software that looks good and does good things. I have nothing against the software applications that are out there, but I think every plant has a historian at this point. You can build simple equations into a historian. Just go do that. You build a couple benchmark pages. That's what we like to do, but it depends.
Thank you.
Yeah, good question. Thank you. I'm kind of boring and old probably in a lot of this stuff. Like, if it works, why fix it? You know, like, anyway, sorry.
Any other questions?
That improving energy efficiency also has a benefit of like improving reliability.
Ooh.
And less stress off.
Yeah, so the question is, by improving energy efficiency, do you improve reliability? That's a good question. I would say anytime we go play in this realm, we find really fun margin wins. So like that example that I showed for going through peak, we had a great win on an FCC wet gas compressor that debottlenecked the cat by a couple thousand barrels a day. Paid for the study in about 3 days. So you don't always have those wins. On the reliability realm, I would assume it's there. But I guess I can't think of like an example that I have been a part of. I would say steam system reliability is one that does come out of these energy studies sometimes. And, you know, you go through these crazy winter wipeouts and, you know, the South, we're not built very well for, it gets below freezing and like every refinery and petchem plant has problems. I think some of these energy initiatives help you go focus on steam leaks, which then kind of drive you to do better through those really catastrophic winter events, and really helps reliability. Sorry, that's one example I can think of off the cuff, but yeah, good question.
We've got a couple of questions online. I think you've answered the second one already. Improving reliability, you improve energy efficiency. That's.
Oh, yeah, for sure. Yes.
That goes hand in hand.
Yes, hand in hand. Yeah, very strong that direction. And don't even try to chase energy efficiency until you're reliable. And it's like you have to be safe and you have to be reliable, and then you can do it. Don't even bother doing it before the other two. Yeah.
Okay, last question. Would a building monitoring system help you identify what the low hanging fruit is?
A building monitoring system? Sorry.
Or would building a monitoring system?
Building a market.
Yeah, let's look at it that way.
Yeah. So yeah, if you don't have that's where like the whole key energy variable KPI thing comes in. Yeah, like you need to build something basic within, like I said, those historians, you can build simple little equations just go data mine, you know, go pull the last 10 years of stuff just in a giant sheet. And where are my correlations? And then boom, you got a polyfit to say, oh, I can definitely do better here. I ran it this way 3 years ago. Why can't I run it that way now? Yeah, it's things like that. That's easy.
Okay, I'll let you have the last question.
Do your clients show interest on energy management systems, and especially on the certified ones like ISO 50000?
So it is like in that benchmarking tool, the peak tool does go look at that. I would say a lot of the refineries that I've interacted with, they don't really care about ISO or what the DOE has said. I would say in the United States, we're probably the most, we're just not going to do that is kind of the feel. Europe is a little bit more focused on the ISOs. Has anybody actually read the ISOs for energy? We got one. There we go. Yeah. Okay. So yeah, we got a handful, and I have nothing against the ISO. It's a very broad framework. You know, it's like, here's the organization, here's how you want to set up the thing. It doesn't kind of get to the next level. Like, so what do I actually want to go look at? Like, what are the behaviors or the culture I want to do? I think that if you just try to go be practical and do good in this realm, like common sense things, you tend to adhere to a lot of what ISO recommends. And I think it's nice to be able to say, hey, we comply to ISO, 50,001. Did I get that right? Yeah, 1 and 2. It's kind of neat, like a little feather in your cap to say, yeah, we do that. We care about it. And in the US, there's Energy Star. That's what I was forgetting. The Department of Energy Energy Star certification. And you can do that if you are a first quartile EII. So that's a good little program too. So, anyway.
Okay, well, thank you very much.